Okay, so welcome back. Now in this playlist, we've been talking about data acquisition, and we started out a while back talking about a more professional data acquisition device called a LabJack and how to set up a very nice user interface in C Sharp. And here's the interface. And we talked about that previously. What we're going to do now is we're going to talk about doing something similar, not as complicated, with an Arduino Nano, but you can use it on the other Arduinos, I think. So we're gonna talk about setting this up, this user interface, in C Sharp. Now, in the previous video in this series, and I encourage you to take a look at it, we set the groundwork for this. We talked about writing an Arduino sketch that we will need to develop this. And now in this video, we're going to talk about the C Sharp end of it. And as we talked about before, you hit the read button and it reads some data from the Arduino, and we print those values, and it's got the microseconds, comma, and value of the sample from 0 to 1023. And then we process it internally, and then we plot it out on the screen. And I've got a 0 to 5 volt sine wave being fed into my A0 analog input of the Arduino Nano. And you can see we plot it out in milliseconds versus volts. So we're gonna look at doing that in this video. Now, in the previous video, we came up with this sketch, and again, I encourage you to look at that to see the simple sketch we developed. Now, before we get into the C Sharp code, I want to mention one line of code that I added to this sketch that we developed last time. And it's this line right here. And after I've gathered all of the data, all of the samples from my burst of data and put them into the arrays, I'm also going to send back to the computer, back to the C Sharp software, a string that says END in capitals. That tells the C Sharp software, hey, it's done releasing all of the data in its arrays that it gathered. In this case, 100 samples. It gathered 100 samples and it sent all those to us. Now we're done. So we can stop checking the serial port. So I've just added this. So after we get this string of data from the Arduino, the last line is going to say end, and then we can deal with that appropriately. So in the previous video, and I encourage you to take a look at the previous video and the other videos in this playlist, we went through and looked at the basic design process and who's going to do what and what the timing is going to be and that kind of thing. So based on that, we're going to lay out this C Sharp code. So now let's start out looking at the user interface that we are going to develop. And you can see it's fairly straightforward. I've got 4 buttons here, and then I've got an exit button. So we've only got 5 buttons. We've got 1 text box, and we've got 1 chart. So I'm going to leave it to you to drag and drop the buttons and the text box. And I've also set this scroll bars vertical. You can see down on the right here, I set scroll bars vertical for the text box. And the chart you can get, just select the form. Make sure you've got the form selected. Toolbox, scroll all the way down, and you can see you've got a chart under data. So just drag and drop that. Now, the chart defaults to a bar chart, so just keep that in mind. We're going to want to change it to a line chart. And also we've got this legend here, which I don't like these legends, so we're going to get rid of that legend, but just keep that in mind. So we've got the 5 buttons. Now, once you've got those, I encourage you just double click each of them in series so we can generate the event handlers for each of the buttons. So we know what we've got on the user interface. So let's take a look at the code. So I've got basically just my Form 1 code, and I'm using, to make things a little bit cleaner, I'm using regions. So you do pound reg and double click, and you get these collapsible regions. I think that's a lot easier to visualize what you're doing. So I've just got my form with some documentation that's empty, a to-do list that's empty, and some initializing variables, global variables, and then my form 1, which I'm setting up the chart. We'll go through this in a bit. I just want to give you the general overview. I've got a few methods here to do some of the work, and they kind of match what the buttons are. And then I've got the event handlers for the buttons. So you should already have, if you've double clicked on each of those buttons, you should have the 5 event handlers. They're going to be empty, but you'll have the 5 event handlers. So you'll be all set to go. So that's about it. The only other thing I've got is I've got a class. So I just went to the project, right-clicked, add new class, and I called it Input Data Processor, okay? And I made it public. Now, I'm not going to retype all this stuff. If you want to copy any of this, just pause the video and type it in yourself. That's one way that you learn. So I've added public to the class, Input Data Processor. And again, I've got regions where I've got the basic properties, and I've only got 2 properties. I've got a constructor, and I've got 2 methods in here, okay? And it's basically just going to process the data we get in string format from the Arduino. It's going to scale the values and convert from the microseconds into actual usable times, okay? So that's basically the general overview of the code we got here, all right? So now let's look at the form code and the using statements. I've got the basic using system, system.windows.forms. I've also added system.io.ports. That's so we can do serial port reading for the USB port. I've also got system.threading, and what we're going to do is we're going to set up a separate thread to read from the Arduino, so the UI will be available. You probably don't need to do this. We're just going to do it because we're going to do it. System collections.generic. What I'm going to do is I'm going to add every string I get from the Arduino as it sends us these strings of time and value. I'm going to add them, each string, to this collection of strings or list of strings. So that's why we need this. And then we've got Windows Forms, Data, Visualization, Charting to do the charting stuff. So that's all the usings we're going to use. Now, like I said, I usually add a region for documentation. It's pretty much empty with this one. I need to add to it. To-do list, I've got nothing. So initializing. Let's first look at the values that we're going to be using, global values we're going to be using in here. So the first one is a Boolean, a public Boolean called end of data, and I'm initializing it to false. Now, I showed you in the Arduino sketch, we added a line to say that when the Arduino is finished sending everything in the arrays, it sends a string that says END. So when this code detects that, it's going to set this Boolean to true. It's going to say the end of data has been reached, so the code can deal with it. So that's just a Boolean letting the code know that, hey, I received an end of data from the Arduino. Now, serial port. I am defining a serial port, which is the USB port from the Nano, and I'm calling it Nano port. That's the name I'm giving to it. Then I am setting up a thread from system.threading called serial reader. Okay, so I am going to put the reading of the data from the Nano port on a separate thread. Now, I've also got, we mentioned we're going to add each string of data we get from the Arduino. We're going to add that to a list of string called input string list. All right, and that's why we needed this collections generic. And then I am instantiating this data processor class, input data processor, and we're calling it processor. All right? So that's all the initialization we're going to do, all the global variables. So now I get into the basic form. I've got the standard initialized component, but here what I'm doing is I'm just initializing some stuff on this chart. All right? So I am setting the x-axis minimum to 0. I am rounding the x-axis values to make them look a little bit cleaner. I'm giving a title to the x-axis called milliseconds. And I am also telling it that we want a line chart, not a bar chart. So chart1.chartAreas, and it defaults to, when you add the chart, it defaults to, the chart name is chart1, and the only chart area is chart area 1. So this should work for you too. .x-axis.minimum equals 0. Same thing, x-axis.roundAxis values. Same thing, title, and then here, chart 1 series, and series 1 is the data that we're going to be plotting, and the chart type is series chart type.line, right? Now, we also mentioned that we've got this little legend up here that I want to get rid of. That's why we're doing chart1.legends.clear. It gets rid of this little legend thing up here, right? So that's all I got in the form, right? So now everything gets initiated by these event handlers, okay? So we said we've got a read button, we've got a print, we've got an exit, we've got a process, and a plot. So the first thing you're going to do is we're going to click this read button, all right? So let's see what the read button event handler does. So we click on this, and this basically initializes and opens the port and initiates a thread to read data from that port, okay? So I've got the button read, and I am instantiating a port called nanoport, is a new serial port. I'm setting the baud rate to 9600, set it to whatever you want. In my case, it comes up as COM8, so I'm setting the port name to COM8. So I'm doing a try catch to try to open the port, and if it can open the port, then I get this exception message, and I've got a message box.show, and let me show you what it says. So I start this up, and the Arduino is disconnected, so I try and read, and I get this message box that says, dude, seriously, you need to plug in the device first. So now we know, hey, it didn't work. I need to plug in the device. And then what I do is I do a return to allow the user to go plug in the device like he should have done in the first place and try it again. All right. So let's do that. So I'm going to read. The device isn't plugged in. So now I've plugged in the Arduino, and now it reads, okay? So that's good. So we've got a nice error handling deal. So we set up the, we initialize the port, we open it. Now what we're going to do is we're going to do the thread. And I'm calling the thread serial reader. And the job of the thread is to run this function, this method that we'll talk about next, which is basically a method in my code called read Arduino. So it's going off on a new thread to read the Arduino so it doesn't lock up anything else, right? Now, the next thing I'm going to do is serial reader is background. I'm defining that read Arduino thread as a background thread. I'm setting it equal to true so that when we end the application, it will shut that down too. And then I am starting that thread. So it's going to start running this read Arduino. Now, just keep in mind that if we're putting this read Arduino on a separate thread, it's no longer the same thread that accesses the user interface, the controls. So we're going to have to deal with that. So we're going to have to keep that in mind. We're now off on a new thread. So if we're going to try and access controls from that thread, we're going to have to work on it. So we've started the read Arduino method. And the first thing we're going to do is we're going to write on that serial port the B that we talked about before, which basically tells the Arduino, okay, stop what you're doing and send me the burst of data that includes everything in your time and value arrays. Okay, spit out everything in those arrays to me once you receive this B. Okay, so that's all we're doing with the read serial. We're setting up the parameters, we're opening it. If it doesn't open, we're sending out a message. And then we're initializing a thread to do this read Arduino method, and we're sending out a B to tell it to do its thing, okay? So that's all we've got in the read serial. Now the next thing, we're going to go to this method called read Arduino. So what does that do? First of all, we're going to keep count of how many strings we've read in from the Arduino. And we're starting out with number 1, strings read count equals 1. Now, we talked about before, we are going to read from the Arduino. When it's sent all its data, it's going to send a final string that says END. And in this code, we're going to detect that. And if we get an END, we're going to set end of data equals true. While we haven't received an end of data, try and catch this actual reading the data from the nano, all right? So this is going to actually do the reading from the nano. So I'm doing a try catch, and I'm starting out with a try, and I am doing nano port, the serial port, read line. I'm reading one line of data from the serial port, and I'm setting that to a string called input string. And that reads data from the Arduino until it receives a new line character. So one line of data. So it will be a string with the microseconds, comma, value. Now, we also mentioned in the previous video, it's going to have more than that in the string. It's going to have a carriage return and line feed. So we're going to have to deal with that when we're reading data. We read the input string and we check to see, the first thing we do, check to see if the string was the end string, all right? So we have an if the input string, and I'm using a trim end, which basically trims the carriage return and line feed, the /r/n characters from the end of the input string. And once it's trimmed those, if that input string equals end, then we know, aha, it's already spit out all the data, so we're done. So that's when I set the end of data Boolean to true, all right? So once that's set to true, it's going to stop going through this loop because it's going to say end of data is false, and it's going to stop reading the nano, okay? Now, if it's not end, and it's just normal data, then we're going to go through and we're going to add that string of data to our list of string called input string list. All right. So we're going to tack one more line onto this list of string. But we only want to do that if it's not end of data. All right. Now, what we're going to do, since I talked before about, since this method, read Arduino, is on a separate thread, we initialized a separate thread. Since it's on a separate thread, it doesn't have access to these controls like our text box. So what we're going to do here is we're going to make it so that it can access the text box. And it's going to write, as it receives data, it's going to count how many lines it's received and print that out onto the screen. Let me show you. So I'm reading, and it's printing out how many strings I read from the Arduino, and it's continually doing that. And this is the code, and you can just copy this to access this text box on the different thread. So I'm using the invoke method, and this is my delegate, all right? Now, that is the try. Now the catch I'm going to leave empty. Now, the other thing I want to do is make sure that if I do have an end of data, what I'm doing, I'm strings read count. So I'm starting out, I've read one string, and then I'm going to increment each string. I'm going to increment the count each time I get a legitimate string, but only if it's not an end of data string, all right? If not end of data, then increment the read, because in our case, there's 100 legitimate strings and one end string. So I don't want to count that as one of the legitimate strings, because I'm going to be setting up my arrays and everything based on that 100, not the 101, all right? So that is the read Arduino method, okay? Now, once we've read it, and let's go back and run this. Once we've read it, it goes through, it received the end, so it stopped reading it, and it counted 100, not 101. The array value was 100, and we added that end string, so it counted 100. Now what do we do next? Well, we go into the print. And print goes through and prints every string in that it received from the Arduino into the text box. So we go to the print button event handler. Now what does that do? That's a fairly simple event handler. For each string S in our input string list, again, we added each string to this list of string, and we are defining the text box. We're appending text with that string. So all we do is we're taking everything in the list of string and putting it into the text box, and we're appending it with a carriage return line feed, okay? Now, the next thing we're going to do is we need to take that string data and make it into something useful. So we're going to parse the data from that list of CSVs. And we're going to run this method, parse CSV list. Okay, very simple event handler. So we're going to go back up to the parse CSV list. Now, what does this guy do? Well, it basically uses this input data processor class to do the work. All right, so it just instantiates a new input data processor object, and it feeds in to that object a count on how many strings that this processor has to process. All right, so let's jump over into that input data processor and see what it does. So here is the input data processor class. All I'm using is system, and I made it a public class called input data processor. Now it's got only two properties, and both properties are two-dimensional arrays. All right? So the arrays are going to be time, comma, value. All right? And I've got an int version and I've got a double version, because we're going to take the ints coming from the Arduino, we're going to parse those numbers into ints, and recall that when we read them, we're going to get ints. We're going to get microseconds as an integer, and we're going to get 0 to 1023 as an integer. So that's going to be the input, and then we're going to convert those to doubles to make them as usable data. So I've got two arrays, one an int, one a double. It's called input int array, input double array. All right. Now the constructor is going to, as we saw before, we're going to instantiate that, and we're going to tell it how many elements to make those two arrays. All right. These two arrays, we don't know until we get the data from the Arduino how many elements to make the arrays. So here we're passing in, once we've got the data, we're saying, okay, we received, in this case, 100 elements from the Arduino. So set up your arrays and process the data. So it's going to have 100 elements of time, comma, value. So now the methods, and there's only two methods that we're going to use here. And we talked in the previous video about the stuff we need to do. First of all, we want to scale the values. Again, we're getting from 0 to 1023. That's of little use. So what we want to do is we want to make those values from, in our case, 0 to 5 volts. So we're saying the values in your input int array are going to be of a range 0 to 1023. So this value will be 1023, and we want them to be doubles with a value 0 to 5 volts in our case. So we will feed it 1023 comma 5, and it will take those values in the int array, and it will convert those to 5 volt values in the and make an input double array. All right, so it takes from the input int array and fills in the double array to scale everything based on these two values. So the first thing, double, I'm defining a double called range double, and I'm just taking this 1023 value, converting it to a double, and then for I equals 0 to the input int array dot length divided by 2, since there's 2 elements to the array. So this is going to give me from 0 to 100. I'm going to go through each value, and I'm going to convert the 0 to 1023 value to a double. And then I've got the double value of the sample, and then I am basically just converting that sample double to a value 0 to 5 volts. Here's the mag is 5 times the sample double. So say if it's 1023 over the range double, if that's 1023, it's taking 1023 over 1023 times 5, and that's converting it to a value of 5 volts to this double array. All right. Now the next method is to make the microseconds into usable data. So all we're doing is we're taking the initial microsecond value, which is input int array 00. So that's that big initial number. So if we run our code and we print it out, it's going to be this number right here, 108,473, the microsecond integer number. And we're just going to subtract out that value from all of the subsequent values so that this becomes 0, and each time step becomes a difference between the two time steps rather than a microsecond value. So the base time is that 0 value, and then I'm converting those raw microsecond times to 0-based microsecond times. So from I equals 0, again, to the input int array length divided by 2, so it's going to be 100. The raw time microsecond, I'm basically taking that value and subtracting out this initial value. All right. So for each 0 value, which is a time value in the int array, I'm subtracting out the base time, which is this first value, and that's giving me a integer, which is the raw time in microseconds. So the first one will be 0, the next one will be like 100, and so on. Then I want to convert that from microseconds into milliseconds. So I'm converting that integer to a double, multiplying times 0.001 to give me milliseconds. So I've now got the value as a time in milliseconds rather than a microsecond since the sketch started. And then I'm putting that as the 0th element in each array. So I'm going through each array value and generating in the double array a millisecond time. So now back to the parse CSV list method, which started all this input data processor stuff. I am instantiating a new input data processor object called processor. And again, I'm feeding it the number of strings in this list of string, which is all the data from the Arduino, with the count of the list of strings. So it's saying, okay, input data processor, instantiate or initialize your two arrays. Okay, I'm feeding it the number of elements, so instantiate your two arrays with those 100 elements, and they're both a size of 100, 2. All right, so that's all that's doing. Now I'm starting out with an int of 0, a counter, and what I'm doing for each string in this input string list, I am doing some parsing to extract the important data. For each string S in input string list, we mentioned in the previous video that they were going to have a carriage return and line feed. For each string I receive, I'm trimming the carriage return and line feed from the end of the string. All I want is the raw numbers. Okay, very important, because if you don't do that, you're going to get all messed up. I am now generating substrings, an array of substrings, where I'm taking this trimmed value, which is the time, comma, value, and I am splitting it based on the comma. So all I'm going to get is a string array of two elements, which is the time, and the other one is the value. So now I've separated those two string values into a two-element array. I'm going to try to parse those as integers. So I'm doing integer try parse subs 0, and then same thing on subs 1. Okay, so I'm trying to parse in this case, the microseconds value, and I'm doing an out. If it's successful, it sends to processor.inputArray I0. It sends out the time, else it's 0. If it can't parse it, it's just putting in a 0 to that element. Same thing with the value, number one element in that array. If I try parse it and it's successful, it's sending out to the input array I1 the value as an integer. If not, it just puts that as a 0. So we're going to see a 0, and we're going to say, hey, something's wrong here. So, and then it's just going to increment for each string, and it's going to keep track of the I. So now at this point, the input integer array has legitimate integer values for the time and for the value. But again, we're going to have to make those into scaled values we're going to zero out the time, and we're going to get the value from 0 to 5 volts. So the next thing we're going to do is we are going to hit this process button. So let's see what the process button does. It processes data. Okay, so what does the process data method do? Well, let's take a look. And all it does is it calls our input data processor object called processor and accesses the two methods. It zeros the times and scales the values. And we're using 1023 because we know we're going to get 0 to 1023 for the values, and we're converting it to 5 volts. And we already talked about what those do. We went through the code. So that's it. We've now generated in the input double array the values of time and value and it's in milliseconds, and it's in 5 volt range. So now all we have to do is plot. First, let's take a look at the plot button. Plot button basically calls the plot data method and feeds in the input double array length divided by 2, again because it's a 100 by 2, so it's dividing to 100, and it's running this plot data method. So the plot data method, again, it's feeding in the number of samples, 100. For 0 to 100, we are extracting out the x value, which is the first value. It's the time value, and we're pulling out the value, the voltage value, which is the first value in the array. And we've got these two, x value and y value. And all we need to do is run this chart1.series, series1 points add xy, and we add the x value and the y value. And that's it. That plots the data on the chart. So really that's the whole code. The only other thing is the exit button, which we do an application exit. It also kills that thread. And that's basically it, and we're all done. So that's basically the code to generate and capture a burst of data from the Arduino Nano and plot it in the C# program. Now here is one we put together a while back for our professional LabJack device. And it's got that burst of data plotting. It's also got a logger function, which like every half second or 1 second, captures and real-time plots data coming into one of the analog inputs, and that's for much lower frequency data. So what we're going to do, I've got a potentiometer hooked up to the analog input 1, and what I'm going to do is I'm going to grab that data and plot it in real time, and then I'll adjust the potentiometer and you can see how it changes the plot. So you can see it gives you a real-time plot and auto scales and everything else. So you can, since you've got the data from the Arduino already, you can do something like that. So maybe in another video we'll add some logger capability to the C# code. Otherwise, hope this helps. Take care and have a really good day. Thanks.